Steps for common monomial factoring. Number 1. Find the greatest common factor of the terms in the polynomial or algebraic expressions. This determines the first factor, which is the GCF. Number 2. Divide each term of the given polynomial or expressions by the acquired GCF to obtain the second factor. And number 3. Express the polynomial as a product of the two acquired factors. Let us have an example. Find the GCF of 135 and 240. So the procedure is to keep on dividing until there is no common factor between the two numbers or expression. Remember, keep on dividing until there is no common factor. So using ladder diagram, we need to get the GCF of 135 and 240. By dividing 5 into 135 and 240, we will have 27 and 48. By dividing 27 and 48 into 3, we will have 9 and 16. So therefore, 5 and 3 are prime factors. Prime factors common to 135 and 240. So by multiplying 5 and 3, so therefore the GCF of 135 and 240 is equal to 15. Another example. Find the GCF of 4xy raised to 9 and 12x squared y cubed. So, remember, we need to keep dividing until no common factors. So, by using ladder diagram, we have given of 4xy raised to 9, 12x squared y cubed. Divided into 2 both. So, we have 2xy raised to 9 and 6x squared y cubed. Divide both again by 2 since they are common by 2. So we have now x raised to 9 and x squared y cubed. Divide it again by x. So we have now y raised to 9 and x y cubed. Divided by y raised to 8 and x y raised to 2. Since we have x divided by y, so we have now y raised to 7 and x y divided by y, so we have y raised to 6 and x. So the common factor are 2 times 2 times x times y times y times y. By multiplying these factors, the greatest common factor of 4xy raised to 9 and 12x squared y cubed is 4xy cubed because y times y times y cubed. Number 3. Factor 3p minus 3q completely using monomial factoring. So we need to get the GCF of 3p and negative 3q. So the common factor, what have you noticed? The common factor of 3p and negative 3q is 3. So divide each term of 3p and negative 3q by 3 since this is the common factor of these two. So by divided by 3p and 3q, so we have now p minus q. So the factored form of the given polynomial is 3 times p minus q. We can check it. 3 times p, we have 3 times negative q, we have negative 3q. Number 4. Factor 12x squared plus 18xy. The greatest common factor of 12x squared plus 18xy is 6x. So, the factor form of the given polynomials is 12x squared plus 18xy. Since the GCF of 12x squared plus 18xy is 6x, we can now divide it into the given. So, 12x squared divided by 6x, we have 2x. 18xy divided by 6x, we have 3y. So, therefore, the answer is 6x times 2x plus 3y. Check. Check it. 6 times 2, 12. X times x, x squared. 6 times 3, 18. X times y, xy. So, therefore, the factor is 6x times 2x plus 3y. Number 5. Factor 32x squared y cubed minus 20y squared. The greatest common factor is 4y squared. Therefore, the factored form of the given polynomial is 4y squared times 8x squared minus 5. Simply divide the GCF to the given. 32 divided by 4 is 8. X squared y cubed divided by y squared, x squared. 20 y squared or negative 20 y squared divided by 4y squared, 5. Since cancel the variable. Factor 39m n squared p raised to 4 minus 13m squared n squared plus 52n raised to 5 and p cubed. Apply common monomial factoring. This will lead to, since the GCF of the given is 13n squared, so we need to divide the first term, the 39m n squared p raised to 4 to 13n squared. So we have 3m p raised to 4, 13m squared n squared divided by 13n squared, we have negative m cubed. 52n raised to 5 p cubed divided by 13n squared is equal to 4n cubed p cubed. So the answer is 13n squared, quantity of 3 p 4 minus m cubed plus 4n cubed and p cubed.